Number 1, determine the equation of the tangent to fx at the point where x is equal to 1. So let's have a look at the graph f for the function f of x, bracket 4x minus 1 outside of the bracket times e to the power of x minus 2 and then plus 1 at the end. This is how it looks like. Okay, let's move this to the side. Where x is equal to 1. So let's go to geometry, points and lines, points on. Remember, even if we enter a value that is not exactly 1, like this, hit escape to go out the drawing mode, and then I can just click here, click again, we can enter the value, and I want exactly 1, and then the point will move to the place on the curve where x is 1, and we see that the y value is 2.1. Okay, so let's draw a tangent. Points and lines, tangent. Just click here, escape to go out the draw mode, and then extend these ends a little bit. Now, menu actions, we would like to know the equation. We just select this one. So this is the equation of the tangent. Okay. So y is equal to 2.58x minus 0.47. Number 2, determine the coordinates of the minimum point of f and x. You can see that we have a minimum around here, so let's use that function. In the calculator, analyze graph, minimum, go a little bit to the left, go a little bit to the right. You can see that this is the coordinate. These are the coordinates for the minimum. Minimum, so minus 0.75, 0.744. They said something about, let's see, for the questions, write all decimals correct to 2 decimal places. Okay, so this will be 74, I'll round it down. Number 3, find the range of values for which f of x is increasing and decreasing. Okay, so when f of x, or the y value, is going down, basically. When the function is going down, the y value, or f of x, is smaller, and then when it's going up, it's larger. So the breaking point is here, because from here and to where x is minus 0.75, f of x, or the y value, is decreasing, is going down, and after this minimum point it increases. Okay, so how do we express this? The range of values for which f of x is increasing and decreasing. Okay, so when you can say decreasing f of x, decreasing for x is less than, and it was minus 0.75, and then we can say that f of x is increasing for x greater than minus 0.75. draw the graph of f and g in this domain. Okay, so basically we just have to have a look. Let's see, -3 to 3. We have to zoom out a little bit to see what's happening up here. How about we just change the window? Maybe we go from -4 to 4. And right now we need to go up a little bit. We can actually start at 0 and maybe go to, let's say, 12. So we go from -3 to 3, and this is 1, 2, 3, 4, 5. Okay, let's trace the function to make sure we have everything. Trace, graph trace. Let's walk around here. So from -3 to 3, see, we have to actually have up to 30, a little bit more than 30 on the y-axis. So let's change the window settings. -44, 0, from 0 to, let's say, 35. Okay, let's get this out of the way. So from -3 to 3, and then we have a minimum here, and then it's going up, increasing. And then we just have to basically sketch this graph with the so that everything looks the same, and be sure that we write out the minimum and also the x and the y-axis to number them correctly. Determine the coordinates of the point of intersection. This seems to be another function, and we have to find out where they intersect. So let's click the tab key. The second function is ln of x plus 2 plus 2 So we have, let's use the box tool. So we would like to have a closer look at this area, because we have two intersections here and here. Let's use escape to go out. Let's use the analyze graph and intersection to the left, to the right. Here we have the coordinates for that intersection point, and let's do the same thing. Intersection to the left, to the right. Here are the coordinates for the other intersection point.